We're going to make a start. First of all, thank you very much for coming along. So many people. It was a little bit surprising that so many people are engaged in this event. Fantastic that they are, and hopefully the quality of the lineup of speakers that we've got will hopefully kind of mean that you go away satisfied and informed. Okay, so. What I'm going to do is I'm going to run through the format of tonight's event. Then, so each speaker is going to come up and they're going to talk for between 5 and 10 minutes. As I've mentioned to them individually, I think I'm going to be quite strict on that. If you do reach 10 minutes, I will cut you off. Don't feel, hopefully don't think me rude if I do that. And then we're going to take questions from this is a good time to introduce the rest of my panellists here. So we've got Eunice Simmons, who is Vice-Chancellor of the University, and we've got Councillor Matt Bryan, who is Cabinet Member for the Climate Emergency within and Housing and Planning as well. Apologies, Housing and Planning as well. So, yes, we're going to ask those questions. If you have questions, you should have been given a slip of paper on your way in. If you can write your question down on that, pass it towards the end. Jill is going to very kindly, we've got a volunteer from Story House who's going to do that. He's going to kindly collect those questions, bring them down to myself. Obviously, we probably, with about 15 minutes between each of the speakers, have time to ask everybody's questions, but hopefully we'll have something solid to go on. Something I should say as well is that on the website, Story House website, it said the event was approximately an hour and a half. We think it's going to run nearer 2 hours. If that's an issue, feel free to leave early. It's not a problem. The event is being recorded. We not live streamed, unfortunately, but recorded, and we'll put that on YouTube at a later date under this title. Besides that, the only other thing is some housekeeping. There's no planned fire alarms, so if we do have a fire alarm, then we're straight out there. But I've been assured that Story House staff will help guide us out. Okay, so the final thing for me to do is to just run through the running order for this evening. So first up we have Professor Joe Howe, who's the chair of the North West Hydrogen Alliance. After that we have the Green Party Councillor Paul Bowers, who's also the ward member for Helsby, where a large amount of the HyNet infrastructure is in. Then we move on to our two virtual speakers of the evening. We have Diarmaid Clery, who's a Post-Doctoral Research Associate at the Tyndall Centre for Climate Change Research, which I'm sure the majority of you are aware of. Then we have Professor David Cebon, who is the Professor of Mechanical Engineering at Cambridge University and is also part of the Hydrogen Science Coalition. Then we have John Egan, who is the the Regional Manager for Progressive Energy. Then we have Don Naylor, who is the coordinator of Friends of the Earth Liverpool. And then finally we have the Member of Parliament for the City of Chester, Chris Matheson. Okay. Like I said, I'm going to try and be as strict as possible on time. So can I invite, and I'm sure we're all happy to give applause, but can I invite our first speaker up, Joe Howe, please.
Good evening, colleagues. I think I should be applauding you for coming along this evening and wanting to listen to me, so thank you very much for coming. My name is Joe Howe. I'm Professor and Head of Energy Research and Innovation at the University of Chester. I'm really nervous this evening, colleagues. I'm not really nervous because I'm proud to be here and presenting what is a fabulous proposition. I'm nervous because I'm going to get grilled by my Vice-Chancellor at the end of my talk. Colleagues, the region is the home to one of the most important industrial clusters in the UK. And the world is watching us right now. And all of you have touched it in one way or another today. I suspect many of you have had a cup of tea or a cup of coffee and used the tap water. Now, where's the chlorine come from in terms of purifying that water? I suggest that some of you have probably used salt at some point today. And recently, maybe you've ridden on salt on the roads, Maybe you've walked on salt and it's kept you safe. Now I'd ask you, where does that salt come from? Maybe some of you recently have had something like a glass of J2O or a bottle of J2O. Maybe some of you have been bold enough to have a bottle of Chilean wine. Where were those bottles made? We live... Oh, I'll go on, I'll give you another one. Many of you may well have eaten some vegetables today or had some meat that's been produced in the UK. Have you thought about where that fertiliser comes from that goes on the land that helps those vegetables grow or feeds those animals? It all comes from our industrial cluster. So I would contend with many of you here, or most of you here, have actually eaten or drunk or consumed or been kept safe by our industrial cluster. It's an amazing place to be. And that's why I came to the University of Chester 7 years ago, because I wanted to work right at the heart of such an important place. And more importantly, I am passionate about the decarbonisation agenda. It's 30 years ago, colleagues, since I started off my career. And at the time, hydrogen was going to be the next big thing. It's never quite happened. But I can assure you that hopefully when you leave here this evening, you'll be convinced that hydrogen is the next big thing. And we're going to talk to you a lot about hydrogen this evening, and hopefully take you on that journey with us, and in due course be convinced that it's one of the key issues to address the climate and ecological emergency that we're going to hear a lot about tonight. Because the only emission from hydrogen is not carbon dioxide, the only emission is water. The only emission is water. So, colleagues, I'm at the University of Chester, and my cluster that I work in, it does emit a lot of carbon dioxide. But I'm proud of the proposition that the HyNet consortium have around capturing and potentially storing that carbon within the area. But talking about salts down at Northwich, think about Tata Chemicals down there and what their proposition is right now in terms of capturing the carbon and utilising the carbon in terms of making a new product, sodium bicarbonate. Perhaps something I should have tonight as I'm about to face the questions from my Vice-Chancellor, and I can feel getting a bit of heart there. We live in an amazing area here within Chester, and so one of the key issues for us is that I think the Northwest has the world watching us right now in terms of the HyNet proposition. As an academic, I'm struck by the number of invitations I've had during the pandemic to go on trade missions or to speak at international events about what is happening in our area. This week alone, I've been to Australia. Later in the week, I'm going to Canada. In a few weeks' time, I'm going to Moscow. Next week, I'm hosting an event with the Baltic nations around hydrogen. I wish I was going in reality, but I will be there virtually and talking at these particular events. The university is doing an awful lot in this particular space. We're co-investigators on the National UK Industrial Decarbonisation Research and Innovation Centre. I'm a co-investigator on that, and the University of Chester is the Northwest academic lead. So today, I think Diarmaid's on the call, we facilitated the University of Manchester having an event around the social licence to operate in the area on industrial decarbonisation. I'm really proud of that work. We're also very much involved in the industrial decarbonisation roadmap for the Northwest, which is working with Northwest Net Zero and the Northwest Business Leadership Team, mapping out industrial decarbonisation across the whole of the Northwest between now and 2050, identifying the key areas, identifying the key clusters, the key technologies, the key financial mechanisms for industry to decarbonise in the locality. And then I'm involved in the HyNet consortium as well. But beyond that, industry in the region has asked me to chair this thing called the Northwest Hydrogen Alliance. And I think that's why I'm here tonight. It pulls together 35 companies now in the Northwest, molecule producers, hydrogen molecule producers, distribution network operators, moving the hydrogen around, consumers, innovators, a fabulous engineering construction sector that's going to build the HyNet network in the area. A lot of different companies together, and our mission is to lobby, to advocate that the Northwest is ready to take advantage of the hydrogen proposition and to become a world leader in the hydrogen economy. At that point, Chair, I will leave it and face my grilling from the Vice-Chancellor.
Thank you very much. Okay, so if anyone has any questions, please pass them along to the end, and we'll collect them and go after. Seeing as he's talked about you so much, Eunice, do you want to go first?
Oh, thanks very much, Chair. I should have said a word.
I think I should do. So good evening, everybody. Thank you, Professor Howe. So in 2 or 3 sentences, what is different to 30 years ago?
The big difference now, Vice-Chancellor, is the fact that industry wants to make this happen. Secondly, there is a climate and ecological emergency, which is much more broadly widely recognised and scientifically proven, and industry wishes to lead the way here in the Northwest to address that particular topic and to realise what their customers actually are concerned about, that climate and ecological emergency. Sorry, 2 or 3 sentences, VC. You said I'm a professor, I talk too long, don't I?
Matt, do you want to go ahead?
What am I asking?
No, you carry on with your own questions.
Well, I'd imagine on the back of everyone's mind at the moment is we're talking about blue hydrogen at the moment, and obviously the long-term goal is green hydrogen. And I did a number crunching with my officers, one of which is up there earlier on, and just in terms of shared land use compared to concentrating solely on wind power, that would be perhaps about 1,500 turbines requiring a minimum of 25 acres per turbine to generate the amount of energy that this is going to generate. And I was just wondering, from your perspective, how soon could we transition from blue hydrogen once this is in place? Because this is ready to go. What's the timescale then until we can go through to a full green hydrogen economy?
You're absolutely right. We're ready to go, and we're putting the infrastructure in place for a hydrogen economy. There's then that transition from blue to green. And indeed, within the Northwest, we already have some major green hydrogen production facilities. They're over at the Runcorn Innovum plants. So there is already a significant green production facility there. One of the big challenges, Councillor O'Brien, is to make sure that we get the business models right for both the green and the blue propositions, so that then we can get some enablers to transition and go on that particular route. I also think there are some fabulous propositions for green around the smaller, more decentralised areas that may well want to consume hydrogen in due course, which is a little bit further away from the networks. I think there's a role for us in the universities and the innovations to support business to pull through those innovations to the marketplace, and for us to actually work with those industries to demonstrate to the financial investors that they are a proposition. So again, one of the amazing things that I've been so lucky to be involved with at the University of Chester is the powerhouse energy proposition, which is taking plastics and turning it into hydrogen. I think there are more propositions around that, around hydrogen technologies, and some of those I might be able to talk to you about in a few weeks' time that I'm actually getting involved with.
Thank you.
Very good. Okay, so one of our hopefully this is coming through okay for the recording. One of the questions that was pre-submitted to us was, I'm going to read this verbatim. So, how will the global price of gas affect this project's viability as green electricity becomes increasingly competitive and gas prices soar?
Yes, I'm doing some work on that at the moment, and I hope to I'm trying to write a paper on that at the moment, because I think there are some interesting issues around that. I think there is a land use challenge around that, and I think the land use will always inflate the price of green hydrogen. And I also think there's a a global politics here as well. Inevitably, it's cheaper to produce green hydrogen in hotter and warmer countries. So maybe places like the Middle East, and to potentially export that hydrogen. That's more of a concern probably in many respects, is the global competition that's beginning to emerge, particularly potentially from the Middle East and also from Russia. And it's going to be exported in the form of ammonia, and we do have a very large ammonia production facility in the area already. And I think the ammonia hydrogen debate may well actually take a precedence over the green-brown debate. And I think that ammonia coming in internationally, they will rubber stamp it, they will certify it as being green.
Okay, thank you very much. I'm going to merge two questions here. One is from James Kelly, and he mentions in the context of the national and the fact that Cheshire West and Chester have also declared a climate emergency. The crux of his question is that what assurances can you give that HyNet won't produce grey hydrogen at any point? And I guess the question for me as well is, what is the driver for the carbon capture, utilisation and storage element of the project? Because in some respects it's an added cost. It's on the end of the pipeline. What is is it regulatory? Is it commercial? What is the thing that's going to make sure that the carbon capture element actually comes to the fore?
I think that's a question for subsequent speakers,
Okay.
not for me.
Okay.
I think the issue for me, however, is the whole dimension of the climate and ecological emergency that the local authorities are actually articulating we're in. They're right, we are in a climate and ecological emergency. The IPCC have declared that we were a matter of years away from 1.5 degrees and the implications of that. That's why it's so important this project goes ahead now, because we need to do something to reduce those emissions and cap those emissions now. Otherwise, we're going to continue with those emissions. We need to do something now to prevent that, to capture those emissions, to utilise them in some contexts, and to store them in other contexts, so that we're reducing the emissions now and trying to avert that 1.5 degrees.
Okay. We've got probably time for one last question. Eunice, Matt?
Can I ask you on the ammonia debate? I think that's also going to be very important. Is it shipping that's going to be using the ammonia? Is that what the story is?
I think shipping will be moving the ammonia. I also think that shipping will be using the ammonia, but I also think that aircraft will be using the ammonia. I also think that maybe some trains and other forms will be using the ammonia as well. So I think there are lots of different opportunities around ammonia, the cracking of that ammonia, maybe into hydrogen, but I think straight utilisation of ammonia in its own right.
Yeah, if you're very quick, Matt, you might just sneak one in.
Yeah, it's just regarding grey hydrogen. From a council perspective, we asked for that guarantee from Cebon and the companies. But my question is, when the national hydrogen policy was consulted on it, it made it very clear that grey hydrogen wouldn't be entertained at all. Yet there are companies at the moment, they usually previously fracking companies are now trying to promote grey hydrogen as a viable alternative, and I was just wondering what the university's stance is with working with such people.
I think it would be great if you'd ask that question of my esteemed colleague next door, but one to you. I think it's fine to work with companies that are committed to the climate and ecological emergency, capturing the carbon associated with that. So if a company was to come along to me and talk about potentially utilising gas and turning it into hydrogen, providing there was a carbon capture component with that, I would have some sympathy with it. I would want to talk to them about what the innovation requirements might be to utilise that and turn it into a cleaner product. And colleagues, before I go, I've got to talk about the opportunities afforded by skills, if I may, Chair, if I've got time.
If you're very quick.
We're in an amazing position here, colleagues. The world is watching us and watching what we're doing with the HyNet proposition and the hydrogen proposition. My students are passionate about this. My students are passionate about sustainability. They're passionate about avoiding the 1.5 degrees and the consequences that might come about that. They're passionate about acquiring skills and opportunities afforded by the energy transition. And I think we owe that to our next generation that are coming through. 20 years ago, 30 years ago, when I was first talking about hydrogen, I was that young generation. Now I want to make sure that the next generation have that opportunity, can have a world and a climate that they can be proud of, and that I can leave them that legacy and equip them with the skills to deal with that and address the opportunities.
Thank you very much. Okay, so next up we have Councillor Paul Barrows. Paul, can I just remind you to stand directly behind the microphone?
Sure.
I'm sure the majority of people in here will be able to hear you. If you didn't, it's just for the recording. It's much better.
Before I start, I'll just make a little statement on tonight's debate. As an environmental activist, I was very reticent about entering into this debate this evening with the oil and gas industry. Not because any doubts I have about the arguments, but because it's never a level playing field. All the witnesses you'll hear from tonight in favour of HyNet are paid to do so, and the resources of a multi-billion-pound industry behind them. Whereas those opposed give their time to fight for the environment without payment. This format means that the public, well actually this has changed a bit, so I'll leave that for this. The witnesses are cross-examined by a neutral panel. This is clearly not the case tonight. Both Chester University and Chester West and Chester Council are clearly integral in the HyNet project. This being said, I don't think they should take away from Chester Sustainability's Forum genuine attempt to have a public discourse. Okay, we'll hear a lot tonight about blue hydrogen being a so-called transition fuel. However, the simple fact remains that it requires huge amounts of natural gas, with all the climate breakdown, environmental, social, political problems that entails. Gas imported primarily from states like Russia tend to leak from pipelines in the extraction, transportation, and later the processing of hydrogen. This is enormously polluting, and we haven't even got to the capturing and supposed storage of the carbon at the other end. Alternatives to importing gas from overseas mean increasing domestic production, opening new gas fields like Cambo or starting domestic fracking industries. Both options are environmentally catastrophic. The truth is, green hydrogen made from renewables and blue hydrogen made from natural gas require two different processes. For this reason, blue hydrogen is not a transition into green hydrogen. It doesn't even make financial sense. I think people will be surprised to learn that the International Monetary Fund, those well-known hippies, have calculated that the fossil fuel industry receives a stunning 5.2 trillion in subsidies annually. The UK taxpayers subsidise this industry at a rate of a staggering £25 million per day. How much carbon could we save with that money was spent on investing in renewables instead? The largest single investment in the world currently is China's renewable energy scheme. I know China isn't a great example of many things, but this is one of them. Its biggest commercial partner is Denmark, with a population of 4.5 million. We're missing out on the real opportunities in the future generation of power. Germany has recently announced that no subsidies will be given to blue hydrogen for this reason. Supporting blue hydrogen will lock us into a fossil fuel industry for decades. We need to be reducing our reliance on gas now, investing in the subsidising of green hydrogen. HyNet's project diverts government funding away from genuine green energy projects and in no way accelerates the UK's transition to net zero emissions by 2050, as is claimed in their glossy PR literature. Investing in the dying fossil fuel industry is backing the wrong horse. Bloomberg, NEF, the research arm of that well-known Wall Street Bible, some more hippies, noted, with blue hydrogen, it's go big or go home. A typical project costs $500 million to build, and there is not much scope to go smaller. Technology only works on large scale. That's an awful lot of risk to bear on a single project. Most companies won't have an appetite for it. Another problem is demand for clean hydrogen, and at those scales they don't exist yet. It's likely before 2030, but by which time green will be cheaper. So large-scale blue hydrogen is actually a curse. Blue hydrogen costs are intrinsically linked to the wholesale gas price, as will be the bills of industry and households alike. Only today, Shell have announced a 14-fold increase in profits on the back of enormous gas wholesale prices, while household bills are set to rocket by 50%, pushing hundreds of thousands more households into fuel poverty. As part of the HyNet scheme, there is a proposal for a hydrogen village. My ward, Helsby, is potentially going to be the world's first 100% hydrogen-powered village. With all the upheaval risks associated with that project, I would suggest that instead of spending money on upgrading pipelines and boilers, which will tie households into fluctuating, unpredictable prices of gas for decades, money would be better spent converting them to electric-powered heat pumps and fully insulating homes to reduce energy consumption and not increasing fuel poverty. As all households' needs can be met by electricity, and only beneficiaries from the conversion to hydrogen are the owners of pipeline networks, which sadly for them must become defunct. Recent compelling research from the US explains that blue hydrogen may have a greater negative impact on climate change than the current use of natural gas. Significantly more natural gas is required per unit of energy if it must be first converted to hydrogen, and then more to power the carbon capture and storage. The result is fugitive emissions and methane during extraction. Incidental emissions of CS2 are also a factor. Johnson Matthey, a member of HyNet, states that their technology permits the escape of around 5% of CO2 in the process of carbon capture. The peer-reviewed paper from August last year states greenhouse gas footprint from blue hydrogen is more than 20% greater than the burning of natural gas or coal. This report by Robert W. Howe and Mark Z. Jacobs from Cornell and Stanford University is widely dismissed by the industry, claiming it uses a worst-case scenario, whereas it claims to be using best-case scenarios. The claims were not disputed in the peer-reviewed process among the US and the most prestigious universities, so I would challenge the industry to provide an equivalent peer-reviewed paper to refute it. Even if the greenhouse gas footprint is less than burning fossil fuel, nothing less than 100% would make it worthwhile. HyNet plans are to store captured carbon dioxide in depleted gas reservoirs in the Liverpool Bay. The paper, modelling large-scale CO2 leakage from the North Sea, concludes carbon capture itself unproven at scale, and only 21 carbon capture and storage projects exist worldwide. There are only 4 blue hydrogen projects currently in operation worldwide, all with very low carbon capture, with the highest being 43% at Shell's Quest facility in Alberta, Canada, and the lowest being 29% at ammonia producer Nutrients plants, also in Alberta. HyNet is claiming over twice the rate of capture that is currently best achieved in this global industry. What evidence do we have to support this? Our carbon dioxide is produced and it is here to stay. If HyNet attempt to sweep it under the carpet, the question must be asked, how can HyNet guarantee that the storage will be permanent, with no leaks from the geological time periods required? It will be incumbent on our descendants to monitor the carbon dioxide stored, just as they have been committed to monitor nuclear waste and disused fracking wells. Given ever-diminishing levels of North Sea natural gas, how can we guarantee energy security whilst relying on imported natural gas from overseas? How can we rely on SR, a key HyNet player, when they've been stated recently that they're on the brink of collapse due to outstanding VAT payments of over £200 million due to the HMRC? SR's accountancy firm, Deloitte, are now being investigated for failing to report poor governance while auditing SR. HyNet seeks justifications for its proposal on the basis that blue hydrogen is a pathway to a distant future of green hydrogen. This is not the case. It is damaging, expensive alternative to green hydrogen, not a stepping stone. Demand for green hydrogen can only be allowed to grow as the supply grows. There is no need to move industries into hydrogen until green is available. It also encourages industries to invest in hydrogen when, in many cases, electricity is a more significant and achievable change and not suitable in the long term, and more suitable in the long term, sorry. With subsidy, the industrial development, low-carbon green hydrogen produced from wind and solar can be developed independently of the fossil fuel industry. Government policy, cheered on by our Labour-run council, are clearly missing the point when they state that HyNet fossil fuel-based project provides a long-term transition to renewable green energy. We have heard this argument before, given by proponents of the fracking industry. We do not have time for long-term transition energy services. This is no need for them. We have declared a climate emergency and the time for a real decarbonisation is now. HyNet's project amounts to a wholly inadequate fossil fuel-based answer to the climate question. It is nothing more than the opportunity for fossil fuel companies to modify their operations in order to sustain business as usual and ever-increasing fossil fuel extraction. An independent life cycle analysis from 2020 concludes the government should approach atmospheric carbon reduction as a public service. This is not something we can leave to an industry with a massive vested interest. And the HyNet project is not something anyone can refer to as green or part of a decarbonisation plan. It is either woefully naive or disingenuous to do so. Cheshire West and Chester's climate emergency declaration of 2019 was not to reduce our carbon footprint by enabling fossil fuel consortia to dump their mess elsewhere and push the problem into the future generations. Chester West is on the front line of the energy debate.
Thank you, Paul.
And the world
I
is
said
watching.
I'd be tough on 10 minutes, and that's exactly 10 minutes, so thank you very much for that. Okay, so once again, any questions, please pass them along, and we'll feed them down. Matt, I'll leave it to you first this time.
Yeah, thank you. And Paul and I go back a long time, and we don't disagree on much, but we do disagree slightly on this issue.
We do indeed, but
and it's not strictly true. This can't be done at a smaller scale, as proven in Runcorn by our former foe, and probably still current foe in Yoss. My question to you is: do you think it's morally right if we diverted all of the renewable capacity at the moment, which is going into the domestic grid? Do you think it's morally right to then create green hydrogen with that and supply it to industry?
if that's what we did, yes, but it's a wider problem than that. This solution, to me, is we live in a dystopia. If we watch a disaster film from the 1980s, the news stories that are on in the background are the news stories we have on in the background now. We are clearly destroying our own life support system. So this is a dystopian solution to that. So the thing that is killing us, we find a way to do less of it, not get rid of it. So it's all about a greater political will. It's not about moving one small part here, one small part there. It's about treating an emergency as an emergency in its entirety.
Eunice, go ahead.
Paul, thank you for your contribution. I think in terms of your explanation, you didn't really differentiate between the industrialisation, the need to decarb the cluster that we were hearing about, and the domestics. So this area has actually created a lot of the problems, is daily creating the problems around carbon. So surely it's appropriate at scale for the next decade or two to actually capture that carbon that's still going to be generated. None of these industries show many signs of abating, notwithstanding SR's somewhat precarious financial situation.
That's completely true. But we're treating something as a local issue, as if we're the only place that exists. But we're starting off here a global industry to keep the fossil fuel industry going for decades to come and to keep extracting. We have to look beyond our own borders and think a lot bigger. So we do have to decommission all these industries. There is no political will to do that now. So this, as I said before, is a dystopian compromise within a death cult.
It's fair to say, though, that there is an imperative on these industries to decarbonise. They have their own targets, and they have government targets to do so. So the problem is, if we don't take action now, in the next few years for these industries and these sectors that are absolutely right on our doorstep to actually take action, we can't wait for the renewables market in this country to generate enough electricity to resolve the industrial aspects of what we're looking at.
Yeah, but that takes into account the fact that we're playing with a straight dealer. We're not. You know, in the COP talks, the largest single contingent was the fossil fuel lobby. The subsidies are £5.2 trillion per year. Everything political around this is distorted by the money.
I would say I was at COP and I did actually go to quite a lot of those discussions. But the issue of the fact we already have a workforce in these industries, we're going to carry on generating these products, we already have this big skills base, we can't not transition this industrial cluster, this belt that we have so close to us, so in the time scale that's required. So if we don't do something, literally in the next 5 years, we will have left it too late.
Well, 3 years ago, we had 12 years left to bring the global temperature down. We're 3 years into that, and the global temperature is still going up. There's bigger issues.
Okay, thank you, Paul.
We've had no questions from the audience, so Matt, if you want to have one last quick question.
Yeah, sure. It's just to raise like a mini case model. In Helsby Port, we've got NSERC, who are the largest glass bottle manufacturers in Europe, and I think everybody would agree that a reusable glass bottle is a good thing. They're also a very, very large energy producer, and they need that feedstock to power the furnaces. And my question is, we can't just close everything down. We can't even put a bus lane in without people running around.
Yeah.
It has to be that transitional, pragmatic. And I'm just wondering what your opinion on is.
Yeah, I know we all want a magic wand, and there isn't one. What we need is a genuine political will, led by a massive groundswell of actually the people. If enough people say no to these, again, I go back to my dystopian analogy, that we are finding solutions with what we consider. Well, people say, what about the real world all the time, don't they? Well, we can prove that the real world is dying because of how we exist. So we have to get out of this real world and find the imaginary world that doesn't actually kill life on Earth.
Okay, thank you very much, Paul. So now we're heading to the first of our two virtual speakers this evening. Diarmaid, hopefully you can hear me, and you're going to unmute yourself now. I think, Diarmaid, you had some slides, so then, as if by magic, you should now start coming through the PA system as well. Can we hear you, Diarmaid?
Hopefully you can hear me.
Yeah.
Someone able to confirm that? Yeah.
Yeah, that's all looking good. Yeah, same applies. Yeah, so, oh well, we gave everybody else a round of applause as they stood up. So
Brilliant. Thank you very much. I'll assume you can hear me, and I'll keep going. Hopefully my Wi-Fi will hold up for the next 5 minutes. Thanks for the introduction. Yeah, so I'm Diarmaid Clery, and I'm from the Tyndall Centre at the University of Manchester. The Tyndall Centre is part of a bigger group of climate change research within UK universities. So what we focus on is kind of quite interdisciplinary research. It can be policy focused, emissions reductions, climate impacts, and public perceptions of climate change, and also governance and policy making. So I'm just going to be talking today mostly about carbon capture. So why are we talking about carbon capture? We've kind of alluded to this already. Haven't been able to see some of the slides, so there might be some similar ones already. But in general, why are we talking about carbon capture? Well, it's essentially to do with global warming. We have set targets to limit global warming to 1.5 or 2 degrees. And essentially that is what matters. And in order to reach that, it doesn't really matter what our short-term or long-term targets are, but what matters is how much CO2 we chuck into the atmosphere, and in the next kind of 30 years or so, and we call that the carbon budget. So where we can see we are now, we're around 2022. So that is the point where our emissions, so what this chart is showing is that our emissions have been growing over the last 20 or 30 years. We're at the point now where we need those to be coming down. The chart is a little bit out of date, but essentially emissions are still going up, and we really need to buck that trend and be bringing them down. They're not coming down at the moment. As long as they keep going up, all that needs to happen is we're going to have a much more radical shift in how we decarbonise and how we reduce our emissions. So it won't be a smoother curve, it will be a much more sudden curve in order to hit our targets of net zero by 2050. So that is something that I think answers one of the questions that was alluded to earlier around what's kind of committing HyNet or some of these clusters to CCS. The answer to that is within the UK that we are committed to hitting net zero emissions by 2050, which I think is important. I think we hear people talking about net zero, and that is what that means. So, sorry, next slide. So what is carbon capture and storage? Well, essentially it is a process where carbon dioxide is extracted from a gas, and it doesn't really matter what that gas is. It can be applied to many different processes. It can be applied to power stations, chemical productions, steel making, glass making, natural gas to make hydrogen, has been talked about. It can be also applied to thin air, which we call direct air capture, and I've done some work on that. It can also be called greenhouse gas removal. But the typical kind of carbon capture process is applied to a power station or chemical processes because they have a higher concentration of CO2 in their processes, typically around 10% or so. So it makes sense to apply carbon capture to those sources rather than direct air, because essentially that is where we are going to increase the cost, because the amount of CO2 in the atmosphere is much less than it is in these kind of industrial sites. So hopefully that gives a little overview of what carbon capture is. Now I'm going to talk a little bit about where it makes sense to do carbon capture within the UK. So this map gives an overview of the emissions within the UK. We can see that the Humber region is essentially the biggest emitter of industrial emissions. The Northwest is also a big contributor. And I think what's important to point out here is that carbon capture offers the only real opportunity to decarbonise these industrial sectors. We can't really do it unless we have some sort of radical social change where we stop using all the things that we're producing in these industrial sectors, which is unlikely to happen if we want to maintain our current lifestyles. I think we've talked about that earlier. There's a lot of emissions that potentially we're not really aware of, but they are there, and things that we're buying are produced in these industrial regions. That doesn't mean that we're not responsible for those emissions. They are still happening, and everyone has a role to play in that. So we're still going to have to do our bit. We're going to have to probably change our diet. We're going to have to change the way we get around, whether that's, well, hopefully cycling a lot more, using electric cars, and certainly flying less. Is something that we're going to probably have to do in the next 30 years. But I think it's important what this map shows is where it makes sense to do carbon capture. So these are the places where you have the high concentration of CO2, and it makes sense to capture the carbon in those places. So I think it's something to be proud of for the Northwest region and the Humberside, and also Teesside. They're the regions that got Track 1 funding from the government to progress their cluster plans. So I'm now just going to move on for a quick slide of what the people or what the public think about carbon capture and storage. Well, typically people don't know about carbon capture and storage. That's what the research seems to find at the moment. People are unaware of it. They're kind of starting to get the idea of what net zero is. But carbon capture is more kind of in the margins of what's being talked about. So the most kind of recent study of what the public think was actually completed by the government last year during lockdown, and they kind of met up with a group of publics in these cluster regions and asked them what they thought about CCS, and what they found is that there is some conditional support for carbon capture and storage, as long as a kind of set of 10 criteria, which are up on the screen now, could be met. So they want to ensure that the process is safe, They want there to be clear benefits for local communities and that the local communities are engaged with as part of implementation of CCS. They want there to be a guaranteed contribution to net zero targets and also, among other things, limited damage to wildlife and the natural environment and minimal destruction to local residents. So I hope that gives a quick overview of what carbon capture is, why we're talking about it, why it's important, and I hope to be able to answer any questions if I can. Thanks very much.
Thank you very much, David. Really appreciate that. So yeah, as we have done for the rest of the evening, I'm going to go to Eunice first.
Thank you very much, Diarmaid. Very interesting presentation. This is a really informed audience. They've given this some thought and they are seeking reassurance about that limited damage to wildlife and the natural environment. I wonder whether you can just say a little bit more about that.
Yeah, sure. So I guess what I can offer in terms of that is my background. I've done some research on carbon capture and storage and the kind of processes that are involved. I guess where the worry would come in terms of impacts on the environment would be from anything that's kind of emitted into the atmosphere that would be harmful to wildlife. The processes that are involved, they go through a lot of kind of cleaning up of exhaust gases before they are released to the atmosphere, and CCS in a lot of ways would actually just be an additional step to that, so it would remove more pollutants than are in there at the moment. But there is regulation in place. Every kind of chemical plant and power station has to submit how much there are limits within which they have to stay under to make sure there are limited impacts on the environment, and this would only be a step to really improve that.
If I can ask one more follow-up question, I'm just going to press you on that a bit because there was a comment about leakages from the storage. So I'm not sure whether you can talk about your models and what you found there.
Leakages on storage from what, sorry?
From the carbon storage.
I mean, my research isn't really in the storage. I get that there's, I think something that I can only really offer is that there is a concern from the public about leakage, but there's no kind of real reason to kind of, no evidence that has found any sort of leakage from sites previously. So I'm reassured by my storage colleagues that when CO2 is stored underground, that it's safe and would be monitored for hundreds of thousands of years.
Thank you.
Thank you, David. Sounds like a long time. Can't job I'm going to sign up. Okay, so one of the questions that have come to us was around storage. One of the other ones that's kind of maybe emerged of a couple of questions again here is what in terms of the most successful carbon capture technology out there at the moment that you're aware of? There was Paul quoted earlier that there's a maximum of 40%. What are you aware of as the maximum percentage captured? I think from what I'm aware of and from my research, it's typically we're looking at about 90% capture on a certainly on a power station basis, where we're talking about it very much depends on the amount of CO2 that's in the gas that you're trying to capture the carbon dioxide from. So typically a power station would be about 10% CO2, and you get about a 90% capture rate on that. I have heard of that you're able to optimize that to hit maybe 95%. But I think then that has impacts on the kind of cost implications and that sort of thing. But I think around 90% is the kind of the typical.
Sorry, I just interject there. I said it was capture and storage, not capture.
Okay.
No, just to say thank you. Tyndall did a lot of our initial baselines for Cheshire West, and my question really is, there's a lot of twitchy people in this room because we got told a lot of promises when the fracking companies came, and I think everybody's automatically suspicious of anybody that wants to drill into a cavity and inject gas into it. And I just want to kind of, I just want to get, I think my views have been made clear. I am in favour of this, but I just want some reassurance in form of some kind of academic materials that everybody can get their teeth stuck into. And I was just wondering if you'd be able to provide those.
I couldn't quite hear the main section of what you were looking for there. It was a little bit patchy.
Any academic materials that we can all have a look at.
That would support what, sorry?
Yeah, just to support the... sorry, I don't need to look at the screen, you can see it. Any kind of academic materials that we can all look at to form an academic opinion would be really helpful. Yeah,
on the storage element particularly, I think is...
On the storage element? Yeah, I'd have to ask my colleagues on that. But yeah, it's very much kind of a bit of a different area. It's more, more geology focused, geology focused. So I can, if you want to send me an email, you should be able to Google my name and find my email, and I'm happy to try and find a colleague that can point you in the right direction.
Thank you.
Appreciate that, Diarmaid. We've got a question here. It's quite simple. How much electricity does CCS technology consume? Is that something that you're kind of aware of, something that you've done some research into?
Sorry, could you say that again? Sorry.
The actual consumption of electricity that the CCS technology itself uses, how does that compare, and what kind of scale is that at?
Yes, so it does use an amount of energy. We typically call that the energy cost, and I think that is an additional kind of 20% when we're thinking about a power station anyway. It does add 20% on, so that means that you're taking away 20% of the energy that would be added to the grid or supplied to the grid, and that's used to process the carbon capture plant. So that is a significant amount of energy that could otherwise be supplied, but I think in terms of where we're trying to get to here with tackling climate change, I think it's a small price to pay, really, in my opinion. But it will mean that that kind of cost is lost, and that might have to be paid for in some way.
Okay, thank you. Okay, one last question from Eunice.
Diarmaid, can you clarify that, thinking about your area graph and the carbon reductions required, that CCS is needed to achieve that very steep decline that you indicate on the right-hand side of that graph?
Yeah, so I think essentially it's getting to the point where we need to throw everything at this climate change challenge. Industrial decarbonisation provides a kind of one of the easiest forms of kind of decarbonising, but maybe not the easiest, but an opportunity, and certainly part of that getting to zero. If we don't tackle industrial decarbonisation, from which, as I said, is kind of the only option is to add carbon capture into the mix. We really won't be able to hit net zero. And also there's industries such as aviation, where I can imagine people are still going to want to fly in the next 10 or 20 years. So some of those sorts of sectors are really hard to offset. There's not quite the technology there at the moment to kind of replace it with electric planes. I think the power isn't strong enough to kind of lift these heavy planes into the air at the moment. So we're going to have to offset those in some way, and greenhouse gas removal provides a way to do that, which uses carbon capture.
Thank you.
Okay, thank you very much, Diarmaid. Round of applause, please. Thank you. Okay, so next up we have Professor David Cebon. Forgive me, David, if I've pronounced your second name incorrectly there. So he is the Professor of Mechanical Engineering at Cambridge University and also part of the Hydrogen Science Coalition. Are you there, David?
Yeah, I'm here.
Looks like we can see your slides and we can hear you correctly. So yeah, let's have a round of applause for David.
Thank you very much for that kind welcome. I apologise for my shiner. I had a fight with my hallway floor and ended up getting stitches in my eye. Anyway, I am going to present some numbers which have been remarkably absent from the discussion up till now. And I don't apologise for that. I think this is a topic which needs numbers, and I hope that they will be clear enough. So I'm going to talk about hydrogen for heating. There are many, many issues around hydrogen. Hydrogen for heating is one of the things that's proposed in the HyNet project, and it's just the one little part of the whole thing that I'm going to tackle tonight. I don't have time to do much more than that. So I'm going to talk about heating with green hydrogen. I'm going to talk about heating with blue hydrogen, and I'm going to draw some conclusions. So here is the first set of numbers. If we start with 100 kilowatt hours of renewable electricity, and you transmit that electricity via the electricity grid, that's about 90% efficient, and that gives you 90 kilowatt hours at the end, at the plug. If you put that into an electric space heater that you could buy at Tesco's, that's about 95% efficient, and so you end up with 86 kilowatt hours of heat in your house. That's multiplying 100 by 0.9 by 0.95. And that space heater is like a little fan heater. So that's a space heater. Suppose we convert the 100 kilowatt hours of electricity to hydrogen. First of all, we'd have to transmit it via the grid. That's about 95%. Convert it from AC to DC. About 95% efficient. And we have to use an electrolysis process on water. That's about 75% efficient. That leaves us with 71 kilowatt hours. We have to compress the hydrogen, which is difficult. We have to transport it, 80% efficient by pipeline. And then we put it into a condensing boiler, which at very best is about 90% efficient. And you can see that we end up with about 46 kilowatt hours of electricity, of heat in our house. So we started with 100 kilowatt hours of electricity. We've got 46 kilowatt hours of heat. That means that half of the energy more than half of the energy was lost. It's actually worse than that. Suppose, on the other hand, we took that electricity and we transmitted it via the grid and we put it into a thing called a heat pump. Now, a heat pump is a wonder of modern technology because it gives you more heat out than you put in. And if you put in 1 unit of heat, it gives you about 1 unit of electricity, it gives you about 3 units of heat out. It works like your refrigerator. Instead of taking the heat out of the butter and putting it out at the back of the fridge, it takes heat out of the land or heat out of the air outside, and it pumps it into the house, and it ends up with 3 times more heat in the house than the electricity you used. So that would give you 270 kilowatt hours of heat in the house for your 100 kilowatt hours, which is a fabulous, magical thing. That's the heat pump. What you can see here is that 270 is 6 times 46. That means for your 100 kilowatt hours of electricity, you get 6 times more heat with a heat pump than you do from a green hydrogen boiler. 6 times. That means you need 1/6 of the cost. The energy cost of heating your house with a heat pump is 1/6 of the cost of heating the house with a hydrogen boiler. More than that, in the case of the hydrogen, we need 6 times more renewable electricity to heat the houses of the country. And this is how this looks. If you use heat pumps to heat all of the houses in the UK, you would need 67 gigawatts of heat. You need 5,600 12 megawatt wind turbines, offshore wind turbines. That's a lot of electricity, a sea area of 9,000 square kilometres. Now, on this graph, the little red things, they're the places where there are existing wind turbine farms. You can see all the wind turbines in the North Sea are these little red things. And there's a few up around in north of England as well. So you can see that the amount of electricity needed just to heat the UK's houses with heat pumps is way more than the existing amount of renewable electricity. In fact, east and west here are the proposed installations at Dogger Bank, and they're very small. If you wanted to use green hydrogen to heat the UK's homes, you need 6 times more than that blue circle, and that's the green circle. You need 385 gigawatts of installed capacity. The UK uses 30 gigawatts on average. So you need 10 times more capacity of wind turbines to heat the UK than the current electricity grid. So it's an absolutely massive amount of electricity needed because of the factor of 6. And that factor of 6 comes from the laws of physics. It's never going to go away. It's never going to change. It will always be a factor of 6, at least, between heat pumps and green hydrogen. What about hydrogen from methane, so-called blue hydrogen we've been hearing about today? You take methane, you put hot steam with it, and you go through a process called steam methane reforming. That's about 69% efficient. And when you capture, what you have to do is capture the carbon dioxide that comes out and put it down a hole in the ground. That takes a lot of energy, and that energy is taken away from the methane. You end up with hydrogen at the end, but the hydrogen is much lower value than the carbon. The carbon is the stuff that burns in methane, and it gives you the heat. So when you strip off the carbon and put it down a hole in the ground, you're left with a rather low-grade fuel. And the energy content of hydrogen is only 11 megajoules per cubic metre compared to 36 megajoules per cubic metre that you started with in the natural gas. So you've degraded the fuel by taking all the good carbon out of it and putting it down a hole in the ground. That's, of course, if someone can pay you to put it down the hole in the ground, because it's very expensive to do that. You compress that hydrogen and you transport it and you put it in your hydrogen boiler and you end up with 45 kilowatt hours of heat in your home. So you started off with 100 kilowatt hours of heat, you ended up with 45. What are the implications of this? The implications, and they're not exactly shown here, but is that it's 1.7 times, you need 1.7 times more input methane to heat, to provide the same heat as if you're going to do it by gas heating. So if you're going to do hydrogen heating, blue hydrogen heating, you need 1.7 times more methane than if you do heating with natural gas. And so that's 1.7 times the energy cost. So if you didn't like the news today that gas bills are going to go up by a factor of 2 because of gas prices, and by the way, Shell has got a 14 times increase in profits, which is an interesting coincidence, then you're not going to like the fact that your heating by blue hydrogen is going to cost 1.7 times more in energy terms. You need 3 times more hydrogen to transmit around the grid to get the same amount of energy because of the calorific value difference. That means you have to replace every pump and every compressor and most of the pipes in the gas grid if you're going to use it for hydrogen power. There is no existing blue hydrogen at scale anywhere in Europe. And the reason for that is that there is no financial incentive to do it. Why would you make blue hydrogen when you could just let the carbon dioxide into the atmosphere and make grey hydrogen, which is how all of the hydrogen, 98% of hydrogen in the world is grey hydrogen. It's 2% of the world's carbon emissions, and the whole lot is made by just venting the carbon dioxide. Why would anybody put it down a hole in the ground when the carbon price is not adequate to do that? There's no financial incentive at all. So there is no reason for people to do CCS and no financial incentive. It would increase UK gas consumption if we did this. We went to blue hydrogen. It would increase UK gas consumption by 27%. And that's a big issue because it would increase gas imports into the UK by 50%, up to 64%. So we now import about 50% of natural gas. This will take our imports of natural gas to 64%. So we're reliant on other countries like Russia, like the Stans, Kazakhstan, like Iraq. They're the countries that provide gas, and we're reliant on those countries for 64%, or would be for 64% of our gas if that was to happen. I'm going to skip over this slide. It shows the rate of decarbonisation, and there's not time. I'll run out of time. The main thing it shows is it will be a decade, 15 years before blue hydrogen is even as good as a space heater, and it will never be as good as a heat pump. You see the heat pump at the bottom and the other lines. You can find them on my blog. One other thing I would say is that the oil and gas industry emits fugitive methane. It leaks and vents and flares methane, and the amount that it lets out into the atmosphere every year is equal to the carbon footprint of Europe. So that is the oil and gas industry just letting methane go because it can't be bothered making its pipes.
Okay, thank you, David. I did say I was going to be tight again, and I am going to be. So that's your 10 minutes. Thank you very much. If you would like to stop sharing now, so we can see your.
I'm the next speaker, and I don't mind.
John Egan's the next speaker. No, 7 minutes for everyone is fair and across the board. Then. So yes, if you could stop sharing now, David, so we can see yourself. Matt, do you want to go?
Yeah, that was a really fascinating presentation, and thank you. My main question, I don't think anybody's under any illusion really about the kind of the emphasis there needs to be on heat pumps, and not getting political, but we had to return, well, we didn't, but the £1.2 billion was returned to the Treasury last year because we didn't have the skills to install insulation, never mind heat pumps. And I was just wondering, from an energy mix point of view, is blue hydrogen something that you would suggest for the industrial? I know you've spoken a lot about the domestic decarbonisation, but we're talking about industry more, because the domestic side is only a very small part of the HyNet plans. I was just wondering what your opinion on that is.
Yeah, absolutely. There are some areas where green hydrogen is essential. And they're particularly the fertiliser industry, which the world's fertiliser industry uses about 1 or 1.5% of greenhouse gas emissions through the manufacture of ammonia. All of that is grey hydrogen at the moment, and all of that needs to be converted to green hydrogen, and that's a lot. The world also uses hydrogen for oil processing, hydrogenation and desulfurization. Some of that will be needed in the future, but in the future we won't have nearly as much fossil fuel being used as a fuel, and so that hydrogen will only be needed for the chemical feedstocks for the polymer industry, the plastics industry, and that kind of thing. Hydrogen will also be used probably for steel making, for glass making. There are a few industrial processes which need hydrogen, and they are the high merit order uses for hydrogen, and they are the places we should be focusing on making green hydrogen, not blue hydrogen, green hydrogen, to clean those up. And that I would consider to be one of the world's decarbonisation problems. How to fix that, how to provide that green hydrogen for those industrial processes which absolutely need it. Not for providing hydrogen for use as a fuel for vehicles, and not providing hydrogen for use for heating homes.
Thank you.
Eunice?
Thanks, David. Very challenging stuff. just have described why HyNet might be successful around here, though, in terms of the glass manufacture, etc. But coming back to your heat pumps, having installed a heat pump, I learned a lot about the fact that they don't work with micro bore. You do get your 3-to-1 if you're lucky, but you have to spend so much on insulation. So you have to dig up every floor, you have to insulate the walls, you have to do an extraordinary amount of work. So for the average housing stock, it's not that realistic to do, because as Matt says, we didn't even succeed in doing a basic insulation problem. So it sometimes needs a supplementary boiler as well. So yes, the tech is great, but people must not underestimate the disruption, the domestic disruption that you need and the investment you need, because there's no subsidy that covers the cost of putting in heat pumps at the moment, good tech though they are.
Sorry, is this a question or a comment?
No, it's a well, it's definitely a comment on the mixed messages there are about how simple it would be if everyone had heat pumps. It's not simple. It would probably be slightly less disruptive if there was hydrogen admixed in the gas, for example. But in terms of your focus, I think, what would you say in terms of the messaging that you would really prioritise now in terms of trying to get people to think differently about the hydrogen use in homes?
First thing is, there are 220 million heat pumps in the world. Heat pumps are absolutely mature technology. They're used very widely around the world, not much in the UK. They're a mature technology. You can go into a shop and buy one today. You cannot buy a hydrogen boiler. You cannot buy a gas pipe full of hydrogen. You cannot buy a hydrogen plant that makes blue hydrogen. You can hardly buy an electrolyser. The hydrogen infrastructure is almost non-existent. So the idea that we're just going to suddenly miraculously have a whole hydrogen economy is frankly not practical. Heat pumps are more difficult to install and they are more expensive than gas boilers. But ultimately, their prices will come down as they're used more. We clearly need to upskill. We need to upskill in the country to have a lot more people who are able to install heat pumps. There's myths around the fact that homes have to be completely turned upside down in order to install heat pumps. You can find many people who tell you that normal houses can be retrofitted with heat pumps with minor adjustments to their heating systems. So I don't think we should get into a warfare about how difficult it is to retrofit your house with A or B. My comment would be, heat pumps are here now and they're 6 times more efficient than heating houses through green hydrogen. We're entering a world where energy efficiency is absolutely crucial. If we're energetically inefficient, we are economically inefficient. If the country goes for hydrogen solutions, it will damage the economy because of the way that it damages our energy efficiency. So we can't afford the energy security problems caused by hydrogen, we cannot afford the energy poverty problems caused by hydrogen, and we cannot afford the economic damage that a hydrogen economy will cause to the country.
Thank you. I have a question that, it says, what happens when the wind's blowing, when the wind's not blowing, but I think it has is more related to energy storage and the production of the renewable energy and how that's used in heat pumps. I'm
happy to discuss that. I have no problem with that. I've written about that.
Yeah,
energy
so go ahead.
Is a big issue in the future electrified world. Energy storage is a big issue, and it's an issue that we have to address, and it's an issue which is not being addressed quickly enough. There are a whole lot of different ways you can store electricity, and if you read the literature on storing electricity, you won't even find hydrogen amongst the candidates because it's so poor. The problem with hydrogen for electricity storage is that you take hydrogen, you electrolyse water, you take electricity, you electrolyse water, you make hydrogen, you store it in some sort of a salt cavern or something, you take it out again, decompress it, put it through a fuel cell or a hydrogen turbine, and the amount of electricity that you get back out of that process is about 30% of what you put in. Now that 30% means that if you are a storage company and you purchased electricity at 10 pence per kilowatt hour, by the time you've gone through storing it and getting it back again, and you've only got a third of it back, you have to sell it for 30 pence per kilowatt hour if you're going to break even. So that efficiency, that so-called round-trip efficiency, is critical. If you lose 70% of the energy, you can only sell the little bit you've got left for a much higher price. Now, if you use pump storage hydro at about 90% efficiency, if you use batteries at about 80% efficiency, if you use liquid air or compressed air storage at about 70% round-trip efficiency, all of those give you back energy at a much lower cost than hydrogen. So hydrogen is not a good solution for storage. Hydrogen is touted as a solution for storage. It's actually extremely expensive. It's not used for storage anywhere, and it just doesn't work. It cannot possibly compete with all of the other storage solutions. So anyone that tells you that green hydrogen is the way to do energy storage is telling you a fib.
Okay, that's the final question. Thank you very much. Okay, so next up we have John Egan, who is the regional manager for Progressive Energy. Thank you very much.
Thank you, Steve. Is that working? Hopefully. Can you hear me? Can you hear me? No. Sounds like it's not working. Okay, I'll shout.
Hopefully the man on the back will sort this out.
Is that working? Go on. No. I'll speak louder. Okay, so good evening, everyone. It really is fabulous to see so many people here for this. For those of us who are doing this day in, day out, it's brilliant to see so many people interested in what we're trying to do. Genuinely mean that. And I fully understand there are people here who maybe don't agree with what we're trying to do. But it's great that we can have a conversation about it. And I really hope that I'll go away having learned something, and you'll go away having learned something. And hopefully that way we actually can tackle the climate crisis. It's a crisis. It doesn't always feel like we're in a crisis. There's so many other things going on in the world. And somehow this slow burn crisis doesn't feel like a crisis, but it is a crisis. It's a massive crisis. It's the hardest thing as humanity we've ever had to try and tackle. There are no simple answers to it. Yeah? Don't let anyone say to you there's a simple or a single answer. And please also listen to those who may have a different opinion, a different way of tackling it, because there is no single answer. There's multiple pieces that need to happen for this. Okay. I think one of the elements that doesn't get enough airtime is the need to move quickly. We're all very familiar with net zero 2050 as our target. Or here in Cheshire West, 2045. Does that work better? Yeah. I don't have to say it all again. So we're all familiar with our net zero target, and it's great that we've got those, but they're the backstop. They're far too late. Okay? And we need to be taking material amounts of CO2 emissions out of our economy, out of our energy system right now. We can't wait for some future nirvana, some new technology, for us to do lots of the things that I've heard described this evening as should. It needs to be are doing right now. And HyNet, and I work for a company called Progressive Energy, we're the overall project leads for HyNet. It's not perfect. Perfection is really, really hard. Right? But what it is something that we can get on and do now. We can start reducing emissions from our industry in this region, which are really huge. Sorry, Dermot, but actually the figures on your chart earlier weren't right. Dermot's chart showed 2.5 million tonnes a year from industry in this area. In the northwest, it's actually 8 to 9 million tonnes a year out of
The Northwest total is about 40 million tonnes a year. It's huge. The great thing is, HyNet is going to solve about a quarter of those. Is it perfect? No. Is it really material? Yes. So do we wait for something else? No, not in my opinion. Should we be working in parallel on lots of other things? Yes, absolutely. But why would we not do something that is going to reduce the emissions in this region by a quarter? That's the reason I changed. I've worked for 25 years in industry. And I saw this project and said, this is something I want to contribute to. This is something I want to work on. Because it can truly make a difference. Is it perfect? Is it the everlasting solution? Is it the only solution? None of those things, no. But it allows us to get on and start making material reductions in our CO2 emissions really quickly from 2025. That's really important. On a large scale like I've just described. And allows us to keep our industry here. There's an awful lot of people employed in our industry. The northwest of the UK employs 345,000 people in manufacturing. That's an awful lot of people. And one way of solving our industrial emissions would be to shut that lot down and send them away. I don't think that's what any of us want, because we know in the end it wouldn't solve the problem. Those manufacturing would move somewhere else. So that's why I'm so passionate about HyNet, because it's material and we can do it at pace. And we can protect the jobs and the skills that we've got, give an exciting opportunity. You know, I've worked in Ellesmere Port for more than 20 years. And let's be honest, Ellesmere Port's had some pretty tough times. But there's actually so much exciting stuff going on. The announcement of Vauxhalls to move to EVs, and now HyNet. Some really exciting stuff. Now I want to talk a little bit about energy. So, David quite rightly told us to talk about numbers, and rightly so. We'd all like to see all of our energy coming from renewables and not have to extract fossil fuels from the ground. So if you take our whole energy system as a country today, all the energy we use for everything, industry, heating our homes, travel, petrol, diesel, gas, the lot. Does anyone know how much comes from renewables today? It's 2%. 2% comes from renewables today. It's not nearly good enough. Yeah, we're actually kind of a world leader. Yeah, and you know, good ambition in the 10-point plan that came out last year to quadruple that. Still means that most of our electricity isn't coming from renewables. So we've got to be realistic. We've got to transform our energy system really quickly and be realistic. And actually, I fully agree. I fully agree that we need the political will that gets us to more and more and more renewables more quickly. But I'm also a pragmatist and say we need to do what we can with what's available today. We need to protect the jobs we've got. So it's about multiple paths to getting to net zero. Okay? We need carbon capture and storage, absolutely. There are certain industries that we simply cannot decarbonise any other way. Take cement production. I'm sure everyone knows there's a plant near Mould, Hanson Cement. There isn't another way to decarbonise cement production than capturing the CO2, because the CO2 isn't coming from a fuel, it's coming from the raw material. You can't change the raw material to make cement with. So we need that. We need hydrogen to decarbonise a lot of our industry. We've talked about NSERC already today. Great company in this area. Some of you may know we demonstrated running the float glass line at Pilkington's at St Helens on hydrogen. These are the real solutions available to us today to decarbonise our industry. We do need hydrogen to help us balance the electricity system. Nobody has yet found a way of keeping the wind blowing 24/7. Not that I know of, anyway. So we need ways that balance those intermittent renewables. And I have to disagree with David that hydrogen is a big part of that. Hydrogen allows us to store energy and then release it to generate electricity when the wind's not blowing and the sun's not shining. It doesn't mean we need it instead of renewables. It means we need it as well as. So, the other correction I have to make on some of the data is Some of the figures used there for hydrogen production simply aren't correct. The processes that we'll be using are a lot more efficient than that. We're using best available technology. So rather than some of the efficiencies talked about there, the hydrogen production will be 85% efficient. Not, I think I said 69%. Is that perfect? No, it's not perfect. I get that. It's an awful lot better than doing nothing. So I really believe that we've got the opportunity in this region to tackle the problems that we've got in this region. HyNet is an important part of that. I think it's exciting. I think it gives our young people opportunity to have careers in sustainable industry rather than dirty industry, which I think is what they want. And it allows us to get on and tackle the emissions in this region. I really believe HyNet is an exciting opportunity that allows us to tackle this huge crisis that's in front of us. And we need to take multiple solutions forward. Okay, thank you.
Thank you, John. Matt?
Yes, certainly. I won't take up too much of your time. I've enjoyed every presentation you've done so far. And
I didn't do any slides tonight, Matt. You'll have been glad to see.
I've heard it about 12 times. So. The main issue for everyone really, and I just saw a question here. Are we wasting our time pursuing blue hydrogen when we could just be going straight into green? Obviously, we've talked about what David did do was illustrate quite how behind we are with renewables, but I think this question will resonate with quite a lot of people that are wondering why we're wasting time going for blue hydrogen when we could be going straight into green.
Yeah, so to me, the key reason, and I, like everybody who believes that hydrogen is a key part of our energy future, wants to see us get to green hydrogen. Utterly agree with that. The reason that I wouldn't like to see us just have that as our solution today is because if we start using our renewables to make lots of hydrogen, they're not keeping the lights on, charging the EVs, and so on. So again, it's not blue or green. It's blue and green, and biohydrogen, and. We've got to be open to multiple paths. One of the troubles I have with the debate at the moment is it's very polarised. That binary belief, it's my solution or your solution, is not where we need to be. I do not believe HyNet is the only answer to the problem. I don't believe hydrogen is the only answer to the problem. But I do believe if we don't get on and start putting in some real solutions really quickly, we're going to have an awful lot bigger problem.
Thanks, John. We haven't talked much about transport and hydrogen. Places like Aberdeen have put in fleets of hydrogen buses. Do you think that is a runner, or is that a distraction? Should we be thinking about other forms of transport, fueling transport?
So, look, I think it's kind of the same point that electric vehicles, have got a lot of advantages. Absolutely, we can all see that, and it's great to see that growing. Clearly, there's a lot of infrastructure that needs to come along to support that, both on the grid and charging points and so on. I think it's really important for the heavier end of vehicles to be exploring alternatives as well, because I think we all know batteries have some challenges, both of weight and their materials that go into them and the recyclability of those. So I think it's important that some good practical research is done on hydrogen-fueled vehicles. Yeah, certainly I'm not going to be the one saying, wow, that's, all our vehicles must be hydrogen. I don't think that would be the right way to go, but I do think it's important to explore whether hydrogen has, certain uses, likewise for trains, where maybe there are lines that it's going to be very hard to electrify, that it's suitable to explore hydrogen. And I think it's important that work's done and find out the practicality. Yeah, forget how many buses Liverpool City region is buying. It'll be interesting to see how that project goes.
Yes, so a question that we asked earlier to Joe when he was talking about one of his colleagues, I presume it was me and yourself, John. And there's another question here related to the emissions trading scheme. So yeah, the question originally was the driver for the CCUS. Is that purely regulatory, or is there or is it commercial? And will HyNet be included as part of the UK's emissions trading scheme?
Okay, so several pieces in there. So first and foremost, let me approach it from the blue hydrogen perspective. So government has consulted on something called a low carbon hydrogen standard, which basically says this is what the footprint of hydrogen production would have to be, whether blue or green, to be considered as low carbon hydrogen. That would enable it to access government support. And basically, if you don't meet that, you don't. So questions like I think Matt asked quite early on around, will grey hydrogen be supported? The simple answer is no. Government won't support grey hydrogen because it won't meet the low carbon hydrogen standard. We utterly agree with that. If stuff is going to be there to improve our climate challenge, it's got to be genuine. Yeah. So it's got to be of a high standard. So we utterly agree with the idea of a standard, and it should be a high standard, and it's based on a full life cycle analysis. So it's not just the process, but it's also the upstream emissions and how the product is used, a true life cycle analysis. In terms of emissions trading scheme, yes, so any residual emissions from the process, so we intend to be capturing 97% of the emissions. It's not perfect, but it's the best available technology. Those would be counted under the emissions trading scheme as well. Yeah. Was there a third part, Steve? I've forgotten.
No, I think that was it. So the driver would be the low carbon standard that's implemented by the...
That's a critical element. So government's consulted on that, and I think intends to finalise that.
And so, as part of that standard, what is the minimum that must be? You mentioned the grey hydrogen wasn't part of it, but what is the minimum percentage carbon sequestered, or the minimum that to be classified as low carbon?
I forget the numbers that they put in the consultation. I think it was certainly better than 90% capture. I can't remember exactly what figure it was. I just don't remember.
Okay,
off the top of my
so
head.
Without 90% capture, the project isn't really viable.
Yeah,
without
and HyNet will be 97%, so we would far exceed that standard. And don't take that 90% number as the right one. I can't remember exactly what they had, but it also has elements in there on the source of natural gas and so on, so that it's a full life cycle analysis.
Okay, we're already over the 15 minutes, so thank you very much, John. Well, if that microphone's still being a bit pants, Don, do you want to take this one? So our next speaker up is Don Naylor, who is the coordinator of Friends of the Earth Liverpool.
Hi everyone. Thanks Chair. Just one minor clarification there. I'm one of the joint coordinators of Liverpool Friends of the Earth, but hey, we're a democratic organisation, so that's absolutely fine. Right, I'm a fairly last minute speaker here, so I am going to read from my script, and I'm also going to start my stopwatch. Okay. So, as I've already mentioned, part of the coordinating group at Liverpool Friends of the Earth, and we as an organisation have, for example, a place at the Liverpool City Region's Climate Partnership, and as John will perhaps recollect, at that partnership we had a meeting towards the end of last year. We did some kind of update review on where HyNet was at, and there was a general helpful Q&A session. A bit more about myself before I go into the main body of what I'd like to share with you all is have been recently retired, have been a trade union environmental rep, so that's a role that kind of very much looks at the interface of social and environmental justice issues. way back, obviously many decades now. I am an astronomy graduate, so I've got a physical science background. And my first job after graduating was with the British Antarctic Survey, a tiny little bit of involvement in the discovery of the ozone hole. It was my manager's quite rightly got all the credit for that. But why I'm particularly mentioning that one right now is that those of us in the audience who, and I imagine it's a fair portion, have read Donut Economics, the kind of around the outside of the donut, there are these given planetary boundaries that we shouldn't breach, otherwise from an environmental perspective we are in deep trouble. And thankfully the ozone hole is one of those measures that is there on the donut, and it's one of the few sectors that we've actually got under control at the moment, because we realise there's a problem and we decided globally to take effective action in sufficient time. So bear that in mind, that's a positive. Thankfully, most of the previous speakers have covered a lot of the technological angles of this issue, so I don't really need to go there unless there are questions at the end, and I'll try and remember my 40-year-old recollection of physical science, but please don't push me too much on that one. Where I'd like to go is considering corporate due diligence from the social and environmental perspectives of HyNet partners, and really suggesting to the audience that these really should be scrutinised. And I want to start off by using a very powerfully illustrative example of what I'm talking about here. So around the time of, well, actually at the time of COP26, obviously not all of us could go to Glasgow or wanted to go to Glasgow. There were various community comings together, coalitions, including one in Liverpool. I believe there was something happening in Chester. Sorry, there was also something happening in Chester. And what we did as part of that in Liverpool was to get statements from some Global South communities, and one of those was provided to us by Friends of the Earth Mozambique. We're very fortunate we got a direct contact with Friends of the Earth Mozambique. So this statement, which if you can bear with me, I'll read that again now, was read out on November the 6th in Liverpool. I think a reference was also made to it in Chester, so you may have heard it before. Citizens of Liverpool City Region, Metro Mayor Steve Rotherham and council leaders, we call on you to cut your partnership with HyNet and end all work with Eni. Eni is a key HyNet partner. Eni is leading the Rovuma liquid natural gas project and is a major owner of the Coral gas project. It's just gone dead, no it hasn't, in Cabo Delgado, northern Mozambique. As a Mozambican organisation which works closely with the communities on the ground in the gas region, we have seen the impacts of Eni on people and the environment before they've extracted even a drop of gas. We have told Eni over and over about the destruction and irreversible devastation they are creating, and every time they have merely waved us away. They always find ways to blame the impacts on other players in the gas industry and never take responsibility for the human rights violations. These projects are not at all aligned with the Paris Agreement, with the environmental impact assessment stating that just the construction of one liquefied natural gas train will increase the greenhouse gas emissions of Mozambique by up to 14%. Cabo Delgado is in the midst of a deadly conflict that the gas industry has been central to. I'm not claiming the cause, that they're central to it. Fighting between the armies of Mozambique and Rwanda, insurgents and mercenaries, has turned Cabo Delgado into a war zone, just like we have seen happening all over the global south when extractive companies force their way in to exploit the land and people, leaving them worse off. While the government and the industry insist the violence is religious, in reality, the gas industry has been central to social tensions for years as local communities see their province's wealth being plundered by national political and international economic elites and extractive companies like Eni. All the while, the complaints and basic human rights and needs are ignored and disregarded. This violence has made 800,000 people into refugees, and thousands have been killed. Journalists and activists have disappeared, some never to be seen again. Eni is watching this happening and continuing with business as usual. We've warned Eni for years, even telling their CEO to his face. To make things worse, Eni has made sure that the people of Mozambique will gain nothing from this industry. Eni and other gas giants have set up subsidiaries in the UAE in order to avoid paying full tax in Mozambique. Mozambique, already a debt-ridden country, will lose billions of dollars because of this. And because they're Eni, they are giants. They managed to get away with it. How do you know they won't do the same thing to Liverpool or Chester? How do you know they won't break their promises, make their billions and leave the city and its people in debt and worse off? Eni talks and talks, spewing lies about the development, in inverted commas, they will bring, but have shown time and again they create havoc, contribute to climate destruction, and then up and leave when they are done, leaving suffering and chaos in their wake. We've told them over and over about the deep social and economic struggles they are creating, but they take no responsibility whatsoever for the human rights violations taking place in Mozambique and refuse to acknowledge that the industry has any link to the violence. Final paragraph. Eni has shown itself to be a perpetrator of neo-colonialism and climate racism. They have no interest in benefiting humanity, the climate, or the environment. In solidarity from the people of Mozambique to the people of Liverpool and Chester, we urge you to distance yourself from Eni. They will bring nothing but disaster. Trust us, they're doing it right now. Right, I find that a very strong statement. We got other statements the other day we read out in relation to deforestation in Brazil, which will get mentioned later, and also deforestation for biomass that's shipped through the port of Liverpool to go to Drax, but that's a different issue. Okay, so let's not put all the blame on Eni. We, Liverpool Friends of the Earth, feel there's a need to apply due diligence to other HyNet partners or supporters. I'm not quite clear of the distinction between a partner and a supporter. I'm sure John could enlighten us. For example, Cargill, here again, implicated in the loss of biodiversity in the Brazilian Cerrado region and indigenous social justice issues. Soya beans for the UK chicken industry are shipped in through Liverpool. To be fair, we raised this with Metro Mayor Steve Rotherham, and he did refer it to the Liverpool City Region Fairness and Social Justice Advisory Board. I mean, he also said, I'm only the mayor, I can't tell the port what they're going to bring in. But he at least said, I'm concerned to hear that. Innovin, an INEOS company, I think there's been one or two mentions already this evening. I'm sure a lot of us in this room recall the attempts of INEOS to impose fracking on communities in northern England, Scotland. For what end? To increase plastic production. I mean, isn't the world super saturated with plastics right now? And the last one I want to call out is CF fertilizers. So going back to that donut economics planetary model, where there are those different sectors where you really don't want to kind of go beyond the threshold. One of those sectors that is massively exceeded already is with nitrate and phosphate chemical fertilizers loading. So isn't that their core business? Why do they need to be part of a solution?
Thank you, Don. Apologies, you're already over 10 minutes, so I'm going to cut you short there. But again, let's have a round of applause for Don. Thank you.
Yeah, certainly. I don't think anybody, again, in this room would disagree with what's been going on in Mozambique, and it's been very well documented, the damage and destruction it's brought to the northern part of Mozambique. It's been horrific. I just wanted to pick up on one point there that you made, because regarding HyNet. One of the first questions that I asked John Egan would he be preventing INEOS from bringing their Dragon ships in with frack gas? And the answer was no. And the second statement was that they'd be using Norwegian gas, where it's not ideal. It does, if you look in gas terms, does. I mean, it's still gas, but it's the best type of gas. If that can be that can be included in the statement. But my question is, in terms of the work that you've done in Liverpool, given that Liverpool uses the same amount of energy as Stanlow does at any given point on any given day, what would your solution be to decarbonising our industrial cluster?
Okay, I'm going to have to try and answer your question, and I will, but I would just like to make a very brief passing reference to the domestic energy sector, because Liverpool's own net zero 2030 plan has actually recognised that because of the the long lead-in time for hydrogen, they don't see hydrogen as part of the domestic energy mix. They're going to focus very much on heat pumps and on solar. So, yeah, it's a very hard practical question to answer, like what are we going to do to transition our industries away from their current high consumptive models. And I think what we need to do is have a massively scaled up community conversation about what the problems are and what the solutions are and what they're not. Yeah, I know there's 100 people here, but really, I mean, there's been some carbon literacy courses run, I know in the Liverpool City region, possibly over here. What have they reached? What, 1% of the population? I don't know how. I mean, we've got educationalists here. We've got to reach out and say, these are the issues. This is the scale of the challenge. It's going to have to involve some massive changes, which we don't think we like. But you'll like what's coming down the road even less if we do nothing. And I'm not suggesting that we're not doing nothing. I just think we have to be prepared to consider the almost unconceivable as a realistic solution.
Thanks, Don. You mentioned your fairness and justice panel.
Not mine,
well,
Steve
not
Roberts.
yours, Steve's. But where in the world would you point to that has a really good way of engaging people in such debates and that's close to industry, that actually makes a difference? Are there any Friends of the Earth partners, around the globe that you think they do it quite well?
Well, Friends of the Earth, as you probably know, is an international organisation anyway. It's been running for 50 years, including in Mozambique. I think perhaps slightly at odds with some of the thoughts shared earlier this evening, that there are increasingly voices within the trade union movement that they recognise the writing is on the wall for certain fossil-based industries. And I mean, some of us will remember that in the early days of the embryonic fracking industry, some trade unions were very supportive of it because they said, so those are our members' jobs. We have to have fracking. What is the alternative? And similarly now with oil and gas workers. So it is going to be difficult, but it is not. It's still absolutely necessary that across the whole spectrum of society, including in the workplace, including academia, including environmental campaigns, including politicians, we have to ratchet up massively, not just the technology, the understanding that the other 98% of the population don't currently have. If we don't do that, we're on a hiding to nothing. Everyone in this room will lose.
Okay, brilliant. Thank you very much, Don. Round of applause. Actually, you can probably just pass that straight to Chris if you like. So our next speaker is a Member of Parliament for the City of Chester, Chris Matheson. Good evening.
The last time I performed on this stage, the town crier locked me in his stocks and went off the interval, so it brings back bad memories. I'm not actually going to speak for 10 minutes. I don't need to. I think everybody else has made such a fantastic contribution. I want to draw on some of the things that have already been said. Eunice made the point earlier that this is a very well-informed audience, and she's right. But we've had 100-odd people turning up tonight. I don't want to assume that everyone knows all the terminology. So you, John Egan, are going to explain the difference between grey, green and blue hydrogen for people.
You get me again. Okay, so first and foremost, however the hydrogen is made, hydrogen is hydrogen, H2. Yeah. So the way that it's produced doesn't affect what the final stuff is. It's not really coloured. The colours are just used as kind of shorthand. So what people call grey hydrogen is what has traditionally been done. So where you take a fossil source, natural gas or something like that, you split it into carbon and hydrogen, and the carbon becomes CO2. And the hydrogen is used, for whatever purpose in steel making or refining or ammonia production. And the CO2 goes to the atmosphere, so it's generally known as green. As grey, sorry. Got my colours right. And sometimes you'll also hear brown maybe used. That's usually where you're using coal as the raw material for that, but same issue. CO2 goes to the atmosphere. Okay. Vast majority of the hydrogen used in the world today is made that way. Blue is what I was describing earlier, so where you take a fossil source and you split it, but you capture the byproduct CO2. Capture a very high percentage of that. The hydrogen is used for the hydrogen, the CO2 gets captured for storage, just like Diarmaid was describing earlier. Green is where you split water. So rather than starting with a hydrocarbon, you're starting with water, and you split the H2 from the O. Right? And obviously for it to be green, it needs to be renewable electricity. Hence my comments earlier about the challenge of the availability of renewable. You will also probably hear about pink. Pink is the term that generally gets used these days for using nuclear power for splitting, either the electricity from a nuclear power station or directly in the process using the heat. And then there's, I'm not even sure what colour is used, maybe turquoise, I think, for biosources. So where you've got biomass used as the source to generate hydrogen. Yeah.
Okay, thanks very much. That's the Cllr for all those who didn't know. I knew, of course I knew it was all about, but thank you for that. One of the features that I've noticed about the debate and the discussion has been something of a polarisation and between hydrogen on the one hand and everything else on the other. And I think one of the lessons that I've got from this debate is actually that this has to be part of a whole suite of proposals that are being brought forward, because as we've just heard, in fact we heard, and John just said it then, we are going to have to take measures. The longer we wait, the harsher those measures are going to be. And so there has to be a whole range. I've got a bill ready to go. It won't actually make progress, but just to make it to when it's my turn in the queue, to change the building regs so that every new domestic property has to have solar panels on, for example. There was a very similar one by a Conservative MP just before Christmas. Heat pumps should become standard in all new housing where it's possible. To put maybe building flats, maybe not. So it would be somebody from the heat pump industry telling me yes, you can in flats. But exactly, yeah. So these should become as standard in housing, and frankly in new industrial units as well. If you're building something, put in the measures, the insulation measures, the heat pump measures, and everything else. I am a little bit concerned about what sometimes appears to me to be purism. If we can't have the absolute perfect version now, then we can't have any version at all. And if we want a green industry tomorrow, we have to start from where we are today. We can't wish an industry to suddenly appear. Now, we talked about numbers earlier. Here's two numbers for you. The first one is that Cheshire West and Chester is, Matt, I'm looking at you, in the top fourth. So I was going to say in the top 10, we're fourth the fourth most polluting or most emitting borough in the country. And that's largely because of the heavy industry. We've got beautiful green countryside. Cheshire's wonderful, but there's some very heavy energy, chems and farms and manufacturing. And the second number that I want to talk about is, I want you to picture the map of this area. Start at about Eastham, on where the ship canal goes into the